Industrial production of food by its intensity of soil exploitation is increasingly harming the environment that struggles to provide stimulating conditions for healthy plant and animal growth. With the employment of precision farming on an industrial production scale, the degradation of food quality escalates to scarce and poor nutrients. Inspired by the contemporary investigation artworks where human-plant-machine interconnections were formed to achieve a better understanding of uncanny phytodynamics, the innovators are invited to empathize with plants beyond understanding them as just raw material. What can be experienced through artistic explorations and the artworks themselves is the need to deepen the interdependent relations with non-human living beings. Through the artistic employment of robotics, biotechnology, and artificial intelligence, we have learned that a balanced ecosystem is imperative for sustainable coexistence. In the residence called Green-Blue-Wall, born from the artistic exploration of the coexistence of plants and machines, a hybrid system of a vertical garden and a robot that takes care of watering the plants is gradually developing. The connection between a sensor system that monitors the needs of the plants and an autonomous robot that waters the garden according to the needs of the plants is the basic form of precision gardening that we are proposing in this project. This allows an optimization of plant care, which uses fewer resources, and harvests in the most appropriate growing phase. It provides a form of precision gardening that enables personalized food production, reduced consumption of land resources, and improved food quality.
This group works as an artist and as an electrical engineer, focusing on sensing. So here we got digital humidity and temperature sensor. There is one on each plant on green wall, and the data is sent wirelessly to a robot, and this is how plant and environment conditioning and communication between a robot and a plant is achieved.
We are in the laboratory of neuromechanics and biorobotics, and this is our first project where we deal with interaction between robots and plants. We developed a robot with 5 legs, and it's shaped like a pentagram, which draws from the golden ratio, which is a symbol of a human. So the design of the robot is challenging also from the engineering perspective, because we don't have many robots which have 5 legs. That's why we had to design everything basically from scratch, from the gait patterns that took into account the energy distribution among the legs, to the way how it lifts legs and moves on the green wall.
Design of the spider robot started out with some off-the-shelf components, such as these dynamic cell motors that are aimed for prototyping robots, and a lot of 3D printed parts so that we could have an accelerated design and development process. We started out by taking inspiration from existing mechanisms on how to design the gripper, and we then went over several different iterations on finding the mechanisms, and we finalized and we designed a mechanism with a kinematic singularity that does not allow the gripper to disengage even if the power is lost on the robot. And additionally, we integrated some microswitch contact to provide some sense to the spider, so the spider can feel when he touches the pins on the wall. And additionally, spring-loaded contact that allows the spider to get electrical power through the wall, so there is no need for external wiring.
The biggest challenge in developing software for our spider robot was actually to design a controller algorithm which would be able to handle both types of movements which are required from the spider. So actually we have 2 types of movement. One is to move a single leg entirely independent from other legs. For example, to move a leg from one pin to another, or to water the flower. And the other type of movements is actually to move spider as a whole system, meaning its body, and that is actually the same as moving parallel robot. In the parallel movement, all legs have to be attached to the wall. The spider is actually moving the bases of these legs according to move its body like this. So, and to achieve high accuracy of these movements, controller needs to run with as high frequency as possible. And this is actually one of the hardest problems we are facing right now, mainly because of communication hardware we are using to communicate with the motors. So actually the only way to solve this is to write an efficient code and optimize every bit of it.